Hello everybody, my name is Max, welcome back to the Lion Ball channel. In today's video we are going to be jumping into part 2 of the Lion Ball pool rack video. You can watch part 1 back on the channel. We did it quite a while ago now actually, but we're coming back to part 2. There's been a lot of updates, innovations, and we're going to be reading through basically the article version of it. So my dad, John Barrett, who has played in our Lion Ball tournaments, has set about a mission to create a sustainable Lion Ball rack, because if you've seen Lion Ball before, if you've played it, you'll know that it requires quite a specific setup of the balls, and we'll even see an example of how it all sets up at the end. So if you've not played it before and you don't understand, then you'll be able to by the end of this video. But let's jump into the article, and this is Lion Ball digitization, additive manufacturing, carbon footprint, and more. Very exciting. So thank you to John for writing this as well for LinkedIn too. So this firstly dives into my connection to pool with my dad. We used to play in the pool league together quite a while ago, back in the day, but it was great fun. And at that same pool club, I used to play with my friend Chris, who you've seen on the channel before, and we played a game that I made called Lion Ball. And as it's mentioned in the article, there's loads of rules on the channel. If you want to learn the rules, you can go and look for the School of Lion Ball Pool. But for this video, we're going to be focusing on how Lion Ball relates to sustainability pillars and how this was designed in a sustainable way for the environment too. Because we wanted to try and make it something that if people end up liking, it's something that can be 3D printed and then done in a sustainable green way. So the first beginning point was to look into additive manufacturing and the digitization. So this was really the start point. This was the stuff you would have seen in the last video we did for the Lion Ball rack, using this Tinkercad system to design the concept for what the rack would go on to look like. So if you look in the middle here, you've got these sort of points where the ball would go into. At Cousins Lounge where we usually play, we measured the ball and then put that measurement into this CAD system so we could work out basically what the inset needed to be that would allow the balls to be all aligned in the same way every single game. And then for the additive manufacturing side, John used Prusa Research. Again, you can find all the links in this article as well, so go to the description, go to the comments, have a read, and you can find all the links to everything we went through. So for the efficiency of the rack, it's very passive because it just stays and exists as a finished piece. The key thing was actually the second point here, which was weight reduction. The original versions, when we were concepting it, had quite a lot of plastic filament that would have been needed. So a huge part of this was bringing down the amount of filament needed so that it's more lightweight, uses less material, all of that good stuff. So using a polymer with a 50% infill was the sort of point where it was still strong enough, but also didn't need any extra adding materials. Then the integration was next. So the printer that we have at our office, it's not the largest printer in the world, it's just got a 300mm build plate. So because of the size of the rack, it's quite a long and thin rack to fit on a 6-foot wide pool table. It needed to be 900mm. So as a result, we had to create it in parts and then join it all at the end. And that was the integration aspect to this project. It isn't one fully finished piece, but if you were to take the bits that we made in the CAD system and build it yourself on a bigger printer, you could design it all in one go. Now, luckily for the durability, there's no moving parts to this, so it's all very much, you just move it into place and take it out. The durability is really good. We used it for the Lion Ball League tournament, which is going to be coming up very soon on the channel. You'll get to see it's used the whole way through the tournament. No risk of anything breaking off. It was really, really cool. So the minimization, this is something we tried to do more of, again referring to the 50% infill as well, and the rigidity needed to be stable, because if it's falling apart then you just end up having to make a new version. So you want it to be that good balance of both rigid but also not excessive material usage. So this is something that we need to track with the embodied carbon and look into in more detail as well, because I do think we could probably get that down a little bit more, which is what John also mentions within there too. Next is onto the reliability aspect. Again, no moving parts. It's great. The key part was the joints, the adhesive joints that we used to connect all the different modules. That was where the main weakness was. There was one instance of traveling the bit from a training session of line ball we did where we practiced with it, transporting it back home where two of the pieces disconnected. Obviously, we just reconnected it as well, but that was before it had time to properly set in, as we were just using it for the first time. So once the adhesive joints had set in, it was good, and there was no breakaways when we were actually using it in the league in any proper testing. But it will degrade away over time. So ultimately what you'd want for a future of this is you'd want a 3D printer that can print the whole thing onto one space, so you don't need those joints. But it is a good happy medium for the reliability. Next is the maintainability. It's maintenance free. You don't have to constantly work on updating it if something's broken. I mean, that goes for the same with all kind of pull racks that you make, right? Because in a pull bar, you don't expect to have to fix your pull rack, do you, or update it? You want it to just exist and live there, like the usual triangles. All these things we don't even really think about. It should just work as it does, as intended. Repairability as well. That's really easy. Again, because it's 3D printed, the obsolescence isn't an issue, and we can design it in the CAD system to be remanufactured, which we had to do on one occasion going from the King of the Hill Shootout Invitational. We had to remanufacture it for Line Ball League. We needed to make it a bit bigger, so it did have to be updated from one version to the next, just because the sizing wasn't quite right. But in terms of that repairability, it's really simple. We do need to upgrade it though, and it has, as I said, just went under an upgrade already. The next upgrade is going to be making it sort of smoother on a pool table, because the material of the table, it didn't so much as snag on it because it wasn't damaging the table, but it can be a bit sticky when you're sliding it in and out because it's not got that sort of smooth surface on the bottom for the sliding action, as is mentioned here, like you would with your normal triangle rack or your 9-ball rack as well. They just slide in and out. It needs to be smoother on the bottom. So that is an update we will be doing for the next version of this. Next is the recycled content. So the filament, it's wound on a cardboard spool. So this is the spool here, which is very cool. Nice to see a nice bit of recycled material being used to house the filament that we use for our 3D printing. Really clever there. Next is the recyclability. So currently looking into new ways of getting new materials, because PETG recycling and disposal aren't able to be used yet. So we need to look at different material options. If you've got a material you'd recommend that we can make future ones out of, let us know in the comments. We are exploring those as we speak. Ease of assembly, it's really simple to build. John put a lot of time into how easy this is put together. Using soya-based biodegradable alternatives are being monitored as well for the ease of assembly going forward, and dovetailing the joints would be eliminated for the need of adhesive as well. Next, we're moving into the disassembly. The joint bonds dissolve as well, which is brilliant. It can be disassembled nice and easily as well, because after its use, after its life, we need to think about its end of life, also trying to make it into a circular product. So once it's done being the line ball rack, there will be use for that material. Now, there's no packaging at the moment. We transport it to and from our line ball events as it is. I just put it into my film equipment bags. I have a bag which houses all my film kit. On one side I can put my tripod, and on the other side I can put the line ball rack. So no need for any extra packaging, which is great. And distance traveled, we made it in our office, so there's no distance that it has to travel itself, but the research needs to take place for the filament transportation costs, because that material does need to make it from where it is put together to us. So we are looking into that as well, because that is a travel cost that hasn't been accounted for. And I'm not going to try and go into all the depth of the embodied carbon. Come and read it for yourself if you'd like to learn more about it. This is John's area. And if you have any questions for John, let us know in the comments. We'll get him to revisit any questions you have at all about the line ball rack, so he can answer them, jump in with that more technical insight as well. And we will be making a part 3 to this video where John will come back in, share more of his thoughts and insights, which would be really cool too. So again, we want to use this video to showcase his article and also build questions that he can answer for the next part. So here's the 3D printer in action, printing the part. You can see it's just putting down the first couple of thin layers as it's building it here. So right at the start of that production process. Here is a photo of the finished rack, which is really nice to see. You've got the 3 little hooks there that allow you to put your fingers in to pull it away once the balls are in position. And it was just such a treat to have this for Line Ball League. I can't wait for you to see the videos. There is, I believe, a photo here. This is at Line Ball League, showing John racking the balls up. And look at that. It's so nice to see the perfect line of yellows and reds. What this means is that every single game of Line Ball, the balls are in the same position every time. It increased the competitiveness of the game because there was no need for anyone to move their balls. You'll have seen in previous tournaments we allowed a bit of wiggle room for players to move their balls left and right if they were sort of too close to each other or too far apart. This wasn't needed in Line Ball League because everyone had balls in the exact same spot every time. The competitive integrity was much improved. And then that's it. So just leave a comment below. Let us know what you think. Do you think the design looks good? Do you think it has improvements? John would love to know. I would love to know. And that concludes looking through his article about how he made a sustainable pool rack for an innovative new pool game. A line ball rack has never existed before, and it is completely new for Line Ball. So again, go and look at the rules video on the channel if you haven't seen Line Ball to learn what's going on, how this is all working. And subscribe to the channel so you can see more videos like this, but also videos of us playing Line Ball. We upload those pretty regularly as well. We've got the Line Ball All-Stars versus the Dover Pool League coming very, very soon. So there's some really exciting content coming up, as well as obviously the Line Ball League. So subscribe, like, comment, all that good stuff. It goes such a long way to getting this to the correct audience as well, so you can all enjoy it together. But thank you all for watching, and we will see you in the next video.